अस्सलाम वालेकुम स्टूडेंट्स, मेरा नाम ज़ीशान अकबर है और आज की इस वीडियो में हम बेरिंग कैपेसिटी ऑफ फाउंडेशंस पढ़ने जा रहे हैं बाय तरज़ागी। लेकिन इस लेक्चर में ख़ासियत ये है कि इसमें हम जो वाटर इम्पैक्ट है या वाटर का असर है या वाटर का जो इफ़ेक्ट है उसको हम कंसिडर नहीं करेंगे। The water effect will not be considered while calculating the bearing capacity by Terzaghi's theory. My name, as you all know, that my name is Ishan Akbar. I am acting as lecturer in the University of Faisalabad. So first of all, we want to introduce that what the foundation engineering is. A foundation is a structure that acts as a support and a jointing medium between superstructure and soil beneath the structures. Or it can be defined as foundations are structural elements like beams and columns which are designed to transfer building load safely to the underlying ground. They must satisfy the following two design criteria: that any foundation you design for any building or any superstructure, it must follow two criteria. First one is the bearing capacity criteria, that the total load of the building or total pressure created by the building must be within the tolerable limit. Mean it must be below the allowable load or allowable bearing capacity of the soil. And next criteria is the settlement. Whenever we design a foundation, we follow two criteria. First one is the bearing capacity criteria, that the applied stress or applied load of the building must not increase the allowable load bearing capacity or allowable stress bearing capacity of the soil. And the second criteria is the settlement, that the settlement must be within the acceptable limits. It means that whenever you start designing a structure or foundation or any structure, the designer or any soil engineer or anyone who is going to tell you the loads, or any design engineer, you can say that it's structural engineer. Whenever a structural engineer gives you a design, it means he will enforce a value of settlement, allowable settlement. Suppose he says that the building or foundation you are going to design must settle less than 2 millimeter or 2 centimeter. So your foundation must settle less than 2 centimeter. If it settles more than 2 centimeter, then it is not following the settlement criteria. Foundations basically are of two types. First type is the shallow foundations, and the next one is deep foundations. A shallow foundation is generally placed within the soil at a depth less than the width of the foundation. It simply means that suppose this is the surface of earth and we lay down a foundation like this one with a breadth or diameter of db. So the depth of footing is d, this one. So the basic requirement for the shallow foundation is that the d must be less than b. So next one is the deep foundation. Shallow foundations include pad, strip, and mat or raft foundations. Pad foundations, also known as pad footings or spread footings, can be square in shape, can be circular, or can be rectangular in shape and carry column loads as shown in the figure 1. You can see here that this is the footing which is carrying this column load. This column is inserting or applying load on this whole footing. And here you can see the cross section that this column, uh, the superstructure is applying load on this column, and this column is shifting the load to this pad footing. Next type of the shallow foundation is the strip foundation or footing. This is also known as continuous foundation. This is important point to consider or to understand, that a strip foundation is also known as continuous foundation. It can be seen in this figure that we have a load bearing wall which is applying load on the foundation, and the footing or foundation that is supporting this wall is known as strip, that this is continuous along the length. And mat foundations can carry multiple columns or wall loads. You can see on the figure, in the figure on right side, that this figure has a lot of columns, but all the columns have same or shared foundation. This same foundation is known as mat or raft foundation. A deep foundation can extend to a depth much larger than the width. In shallow foundation, we studied that the depth of footing must be less than breadth of footing. But in deep foundations, they can extend to a depth much larger than the width. Here, the criteria changes that D may be greater than breadth. Here, this is D less than B, and here the criteria is D greater than B. This is just a thumb rule. Deep foundations include single pile, pile groups, and grid shaft. We can see here in the figure that this pile is a single pile, and here we can see the group of piles, and same these piles may be drilled. Width and length of the foundation are denoted by B and L. We generally denote that suppose we have a footing like this, and length of foundation is L and breadth of foundation is B, and the depth you can see sorry, we draw foundation like this in previous slide, that this is known as the depth of footing, or simply it is also known as the F, the depth at which the foundation is placed by df. This depth is denoted by df, and if a load q is acting, if this load q is acting on the footing of breadth B and length L, then what will be the contact pressure of the footing or load per unit area? So this load per unit area will be equal to total load divided by area. Simply, as we know that F per unit area, force per unit area is denoted by pressure P. Here P is replaced by Q by F, and area is always B cross L. So you can see here that this footing, a P is acting or Q is acting at this point, and this dimension is known as L, and this dimension is known as B. So simply we can divide this Q by B and L, then we will get the contact pressure of the footing. So simply the contact pressure is the ratio of applied load to the area of the footing. So this is the interface between the pad foundation and the soil. This is interface, that last point or last line or last point of the footing and the soil. Bearing capacity is usually calculated with the Carl Terzaghi theory. Carl Terzaghi is the big name in the foundation and soil engineering and geotechnical engineering. So simply we will calculate the bearing capacity in this video by using Carl Terzaghi theory. So the contact pressure at which shear failure takes place. This is general shear failure. The contact pressure. So this is Q. The contact pressure at which shear failure or general shear failure takes place within the surrounding soil is known as the ultimate bearing capacity. It means that we have increased the load on the footing to a extent that the shear failure will occur on the soil. See in this figure that we have increased this Q to a limit that the soil beneath the structure will damage. It will collapse due to increased load. So the shear stress or shear contact pressure at which this shear failure will take place in the surrounding soil of the foundation is known as ultimate bearing capacity. Here ultimate means the maximum stress that the soil can bear due to a superstructure. And bearing means to bear out or to stand with, and capacity is the original requirement or original imposed load on the structure. So ultimate bearing capacity is the maximum contact pressure that a soil can bear from the superstructure. There are various methods to calculate the ultimate bearing capacity of a soil, like Terzaghi, general bearing capacity equation, Meyerhof, Hansen, etc. There are a lot of geologists who have developed formulae to calculate the bearing capacity of soil. But here we will only use the Terzaghi theory. Mostly used method for determining the ultimate bearing capacity is Terzaghi method, which is simpler and quicker. So here in this video, we will consider the no water case, that no water is present below the footing or on the ground surface. So we will consider the dry soils in this video. So if you are going to determine the ultimate bearing capacity of a square foundation, then you will use this formula. Here C prime is the cohesion cohesion of the soil. Mean this is also known as undrained strength of the soil. NC is the bearing capacity factor. Here Q is the contact pressure. I have told you that Q is the contact pressure. This is mostly determined with the help of gamma, unit weight of the soil, and depth of footing. I will let you know. 0.4 is the factor, gamma is the unit weight of soil, B is the breadth of footing, and N gamma is the bearing capacity factor. So there are three bearing capacity factors: NC, NQ, and N gamma. These factors will be determined with the help of table 6.1. I will show that table on next slide. This formula is used for circular foundation. Other factors are same, just there is a change of 0.3. This fraction is changed. And next formula is for strip foundation. Here we can see that 0.5 is used instead of 0.3 and 0.4, and 1.3 is removed. So simply, table 6.1 can be used to determine the bearing capacity factors according to phi dash. This phi dash, you can see here, this phi dash and this phi dash, this is known as angle of internal friction. So depending upon the angle of internal friction, you can get the value of NC, NQ, and N gamma. Simply, this phi dash will be given in the question. So Q is the bearing pressure or bearing stress. This is known as gamma, unit weight of soil, multiplied with the depth of footing, df. And C is the cohesion of soil, C dash. Phi dash is the angle of friction of base soil. B is the diameter or width of any footing. If it is circular footing, then it will be diameter. And if the footing is square or continuous, then it will be the width. And gamma is the unit weight of foundation soil. Here, because we are considering the dry soil, so gamma will be the dry unit weight of the foundation. And allowable bearing capacity is always equal to ultimate bearing capacity, which you will determine using the formulas of circular, square, or strip foundation, and you will divide this ultimate bearing capacity with a factor of safety. This factor of safety will be given in the question. Fs is the factor of safety of a project. So let's move towards the first example so that you can learn the process clearly. A 2-meter wide strip foundation. This is strip foundations, means this is a continuous foundation. This is a continuous foundation. So here this is 2 meter. So B is 2 meter, is placed at a depth. So depth of foundation is always df. So this is 1.5 meter within a sandy clay where C prime, we know that C prime is used in the formula. This is 10, phi dash is 26, gamma is 19. Determine the maximum wall load that can be allowed. We have to determine the wall load Q. This is capital Q, because this is load, this is not bearing capacity, and this is allowed load. So mean we have to calculate QA or simply Q on the foundation with a factor of safety of 3, and here the value of Fs is equal to 3, assuming general shear failure. You can see here the formulas, these three formulas, they are only valid for general shear failure. This formula for square foundation, this for circular, and this is for strip. These all formulas are only for general shear failure. They are not for local shear failure or any other failure. Simply moving towards the solution of this question, so formula used for the continuous or strip footing is C prime NC plus Q NQ plus 0.5 gamma B NQ. And we can see here that from table 6.1 for 26 degrees. You can see here the phi dash is 26 degrees. So we will move towards the table and along 26. See here the 26. NC is 27.09. NQ is 14.21 and N gamma is 19.84. We can see the same values there. Here 27.09, NQ is 14.21 and N gamma is 9.84. So simply Q, we have determined NC, C prime is given here as 10 kilonewton per meter square. Q, NQ, we have got NQ, we have got N gamma, we have B, we have gamma. Gamma is 19 and B is 2. So only remaining is Q. Q is equal to gamma df gamma is 19 and df is 1.5, so it will be 38.5 kilonewtons per meter square. When we put the values, c prime is 10, nc is 27, all the relevant values are entered. This 38.5 is not entered here like this is entered like this, so final answer will be same. When we calculate, the ultimate bearing capacity of the soil comes to be 862.8 kilonewton per meter square. But the question is about determine the maximum wall. Sorry, we have to determine the maximum wall load. So Q allowable is equal to Q ultimate over factor of safety. So ultimate is 862.8 and divided by 3 because Fs is 3. So the total load will allowable load will be 287.6 kilonewton per meter square. But this is a stress. We have to determine the load. The unit of load is kilonewton. So what will we do? Because this is a strip footing, its length is not mentioned, only breadth of the footing is mentioned. So what will we do? We will simply multiply with the B. This Q allowable will be multiplied with 2 to determine the load per unit length. If length of the footing is given, then we will multiply with the length. This meter will be cancelled and total load will be determined. See the example 2. A design requires placing a square foundation at 1 meter depth to carry a column load of 1500 kilonewton. Simply, the load here Q is 1500 kilonewton and df is 1 meter. At a depth, a foundation is required, foundation design is required to keep a footing at 1 meter to carry a column load Q of 1500 kilonewton. C prime is given, phi dash is given, gamma is given. What should be the width? Here the question is changed. He is asking about determining the width B of the footing. So this is a square footing, square foundation. We will use the formula for square foundation. What is ultimate bearing capacity of a square foundation? It is given by this formula: 1.3 C prime NC plus Q NQ plus 0.4 gamma B N gamma. From table 6.1, as we did for 26 degrees, now for 24 degrees, NC is 23.36, NQ is 11.4, and N gamma is 7.08. So by proceeding this solution, we can get here, what will be Q here? Small q. This will be gamma df. So gamma is 15 here. So you can see here 15. Sorry, gamma is 18.5. So 18.5 times 1. And NQ is 11.4. And when we calculate here, we don't know the B because he has a question for us to design or determine the value of B. So we will put B as it is here in the question. So it will be 52.4 B plus 666.4 kilonewton per meter square. So he has given us the total load 1500. So how Q is determined? Q is always equal to allowable load is always equal to our bearing stress is always equal to Q over B into L. Here the given Q is 1500 and BL means B and L for square footings are same. So both dimensions of a square footing are B, so it will be B square. So here we can see that 1500 over B square is the allowable given load or allowable total capacity of the soil below the foundation, and allowable capacity by the formula is by dividing ultimate by Fs, and Fs given is if it is not given you will always use 3. Keep in mind, if factor of safety is not given in your question, then you will always use it as 3. So the ultimate capacity is 52.4 B plus 666.4 divided by 3 is equal to 17.5 B plus 222.1. So simply, if we equate, this is also allowable bearing capacity or allowable contact pressure. This is also allowable bearing capacity. So this one and this one are going to be equalized. Here you can see that these both are equal. 1500 over B square equals 17.5 B plus 222.1. When we solve this by using calculator or by iterative methods, we find that B is equal to 2.4. We will get two answers. One will be negative and one will be positive. So length can never be negative. So we will adopt B equal to 2.4 meters. Okay, this is the second example. So I have set two practice questions for you. This question has three parts. First question is for square footing to determine the bearing capacity, ultimate bearing capacity, and next one is circular, and next one is for continuous. Here R can be a random number. You can see R in every point, everywhere. You can use R between 1 and 5. Simply there will be no problem while solving the questions. So you have to determine only QU for all these three parts, A, B and C. So question 2 is similar. Here you have to determine the maximum column load Q as we did in example 1. Just here the footing is square. In that question the footing was strip footing or continuous footing, but in this question the footing is square footing. Thank you very much. You can contact me if you have any issues or comments. And if you like the videos, please subscribe my channel and share this video with your friends. Thank you very much. Take care. Allah Hafiz.